Back at the shop, Celeste, I'm picking up some gear here for the house, some plates. Operation White Room is a resounding success. Be picking up some black paint soon. For this talk, I want to quickly go over chemistry of life from the perspective of Earth being a cooling star by Ivo van der Rohe. He recently put up a new paper on Vixra. Of course, the references issues were raised with the new Vixra editors, I guess you could say. I haven't seen version 2 yet put up, Evo, but I'm sure you're probably working on it, or maybe it got hung up somewhere. But seeing papers like this is really great for lots of reasons. The reasons that stick out immediately are, well, other people see it, other people understand. The richness of stellar metamorphosis is far beyond my own capacity to fully do justice. To get people to work on it on their own and to ask more questions and to branch out, so to speak, is essential to the development of this new theory. Ivo says, it says here, his abstract, this paper explores the chemistry of life origins from the perspective of Earth being a cooling star. It's very, very, very rare to see a paper like this. And there's a lot of good points here. I'll go ahead and read up some good points. And of course, he did an expose about how RNA and DNA can form and what chemical precursors, where they start. He says near the bottoms of the oceans, where the pressure is a lot higher, a lot of material can form. I'm not against that at all. I mean, my big thing is he just says it all over the place. Earth is a very old star. So the chemistry of life, I think the main issue here happens inside of the Earth itself when it was a much hotter, younger, larger star. And yes, star, not just planet. And he says that quite a few times. As long as we keep on that track, we're on the right track. The details need to be worked out, of course. I can't work all the details out by myself, so that's why I'm going to read this out to you. I'll read out the first page and just sort of give an overview. I don't want to read off the whole thing. I'll let you guys do that yourself. I'll link it to the bottom. It says here, current understanding in science, current understanding of life formation, chemistry has always been Earth's earlier atmosphere. Chemistry has always been in Earth's early atmosphere. In this atmosphere, molecules form chemically that can be considered life's precursors. And he says, as in a puddle, all these chemicals came together to sprout life, to create life. And other scientists claim life or life's building blocks, the precursors, came from outer space, where they were made in astrochemical processes. He says there are problems with this understanding. It says here, a free elemental nitrogen, although nitrogen could have been ionized through electrical discharges, it is an extremely reactive component. The only way sufficient nitrogen could have been free to create the molecules we now are composed of is to take this from an elemental perspective from the very start. And afterwards, nitrogen gets freed with huge lightning discharges, such as Saturn and Jupiter's atmospheres have. So Earth at one point could have had the same atmosphere as Jupiter or Saturn. And I think that's essential. When scientists, when they look at the Earth, they don't look at it as being vastly different in chemical composition. They just think, oh, well, nitrogen's here. So how did we free all this nitrogen up? Well, it had to be lightning. But what about when nitrogen was free, when it was ionized? Back very early on when the Earth was very, very, very young and energetic. All the nitrogen was free. All the oxygen was free. All the hydrogen was free. You had elemental components of the star to work with from the very beginning. So there's that. All that energy is already there. 2, a reducing atmosphere. It is argued that Earth's atmosphere did not contain a reductive, meaning hydrogen and carbon monoxide atmosphere. So the experiments conducted by Urey and Miller could never have taken place. I don't know if you guys are familiar with it, but the Miller-Urey experiments showed that the precursors to life, the amino acids could be formed just from heating up and electrifying carbon, nitrogen, hydrogen, and oxygen. You could just put those in a flask, put electrical discharge through them, and they naturally combine together to make the base components of amino acids. But it's argued by the scientists that Earth did not have that reducing atmosphere. But yes, it did have that reducing atmosphere. We can observe very young Earths. They're called Saturn, Jupiter, Neptune, and Uranus. And even younger of those versions are like the Sun. Number 3, in outer space, no more than 150 different types of molecules have been observed. Yeah, they're not working with a lot there. If you're going to form life in outer space, you need hundreds of thousands of different molecules. Formation of molecules in outer space takes ages. It takes processes up to 80 million years to form a single molecule. It's because they don't run into each other. Vacuum is very vacuumous. For the mean free path of a particle in some places in deep space are a whole meter, meaning there's no gas pressure whatsoever. It's a hard vacuum. Mean free path means if you take a molecule, how far will it go on average before it hits something else? So the number of collisions that can take place with a nitrogen and another nitrogen to form nitrogen gas, it doesn't happen very often. Versus if you had a really thick atmosphere with all that nitrogen already there, colliding with itself hundreds of trillions of times a second. I mean, the comparison, there is no comparison. It's just not the same thing. In just a puddle, not enough material can come together to form a complex protein structure. Yeah, there's not enough chemistry happening in a puddle, in just water. You need a lot more than that to make things happen. The puddle cannot fold a protein structure in such a way that it will be capable of polymerization in a new genetic chain. So that gets to the really advanced stuff. We're talking about folding proteins to make things twist and spin and change shape as they form. That takes an incredibly turbulent atmosphere. It takes an incredibly long amount of time. As well, it takes a lot of molecules, different types of molecules interacting with one another. And to sum up this first page, I don't want to read the whole thing out, but to sum up the first page, it says, he hopes this paper explains why it is best to view this entire life formation process from another perspective than just the vision that Earth used to be a bit hotter and a little different in composition. It was very, very hot, and it had a huge atmosphere that caused a huge amount of chemistry. Earth was a star that captured a lot of material and cooled to its current state. And that's basically the gist of it. In order to form life, and he says here, you need a lot more than that. And that's what Southern Metamorphosis also says. It's the exact same thing. Evo is spot on with this paper. Life is direct evidence that you are standing on what once was an enormous star, Earth. We are the direct evidence that Earth had to have been incredibly huge and energetic, because it takes a lot of energy, a lot of time, and a lot of chemistry to make life. You just don't randomly assort it together in the vacuum where molecules barely interact, where there's essentially no gravity, there's no atmospheric pressure. You do it exactly where it's found. You form life exactly where it's found, on old stars. All right, Evo, thank you so much for writing the paper. I hope the references portion of the new one, the version 2, goes up. I know the new editors of the Vixra, they are a bit more sticklers for details. They want to push Vixra as being a more scholarly type organization. Of course, they chewed me out a few times for a few things that I've written, so I've had to correct some other papers myself. But all right, take it easy, you guys.